Hi everyone, welcome back to my channel. This is Mr. Budihas, your online math teacher. In today's video, you will learn patterns and sequences. Let's start with the word patterns. Patterns refer to the usual types of procedures or rules that can be followed. It can be numbers, shapes, or objects that are arranged according to a rule. Patterns are useful to predict what came before or what might come after a set of numbers that are arranged in a particular order. For example, in this figure, we started at one dot only and followed by three dots, in which it forms a small triangle, and followed by six dots, and it forms a big triangle. Then we have 10 dots, and it forms a bigger triangle. Now, if we want to know the next bigger triangle, of course, we can answer that because in this figure, it has a pattern. Next example is the set of numbers 1, 2, 4, 7, and 11. Now, let's see if this example is or has a pattern. Now, we will determine the gap of each terms. From 1 to 2, there is a gap of 1. And from 2 to 4, there is a gap of 2. And from 4 to 7, the gap is 3. And from 7 to 11, the gap is 4. Now, as we observe here in the red color, there is really a pattern for this set of number. Then we can say that this is an example of a pattern. Sequence. It is a set of values that follow a particular order. It can be finite or infinite. Finite sequence if we can count the number of elements in a sequence, and infinite sequence if we cannot count the number of elements in a sequence. Take note that the sequence is the follower of the rule. And the rule that I am talking about is the pattern. Now, for example, in this set of numbers, we have 3, 6, 9, 12, and 15. The pattern here is we are going to add 3. From the first value, we have 3 plus 3, we get 6. Then we have 6 plus 3 is 9. 9 plus 3 is 12, and 12 plus 3 is 15. Now, the pattern there is 3. We just add 3. Now, the sequence is the arrangement of this set of numbers. That is the sequence. Again, the sequence is 3, 6, 9, 12, and 15. And the pattern is you just have to add 3. Now, this type of sequence is finite because we can count the number of elements here. We only have 3, 6, 9, 12, and 15. It has an end term which is 15. Another example is the sequence 5, 6, 7, 8, 9, and so on. So there is an ellipsis symbol here. It means that there are more elements after 9. And we cannot count that anymore because it goes positive infinity. Therefore, this sequence is an infinite sequence. Another example of sequence is this 2, 4, 8, 16, and 32. Now, take note that there is a pattern here. The pattern is you just multiply it by 2 starting from the first value, which is 2. 2 times 2 is 4, times 2, 8, times 2, 16, and 16 times 2 is 32. Now, the last number here, or the end term, is 32, meaning to say that this sequence is a finite sequence since we can count the number of elements here. Another example is we have this sequence 5, 10, 15, 20 up to 100. Though there is a symbol of ellipsis here, but there is an end term. Therefore, we can consider this sequence as a finite sequence. Next is term. Term refers to each value in a sequence. For example, in the sequence 5, 6, 7, 8, 9, and so on, the first term there is 5, the second term is 6, the third term is 7, and so on. To get the nth term of this sequence, we will be using the expression n plus 4, where n is a positive integer. When you say positive integer, that is also known as the counting number or the natural numbers. We have starting from 1, 2, 3, 4, 5, 6, and so on. Now suppose you want to know the 105th term. Of course, you will not be using the listing method. You will not list all the numbers there for you to find the 105th term. You will be using this general term or this expression in order for you to get the 105th term. Now, substituting 105, since we want to know what is the 105th term, we will plug in 105 here in our n, then plus 4. So 105 plus 4 is 109. Therefore, the 105th term is 109. The last terminology in this lesson is series. Series is the sum of the terms in a sequence. For example, the sequence 5, 6, 7, 8, and 9. Then you are to take the series. Just take the sum of the terms in this sequence. So you have 5 plus 6 plus 7 plus 8 plus 9, which is equal to 35. Another example is the sequence 2, 4, 8, 16, and 32. To get the series again, you just have to add all the terms in this sequence, and we have 2 plus 4 plus 8 plus 16 plus 32, which is equal to 62. This number 35 and 62 is what we call the series. At this time, we will be solving problems about patterns and sequences. Number 1. Find the first 5 terms of the sequence whose nth term is a sub n is equal to 5n minus 3. To solve this problem, we have to think what are the values of n here. Now look at the given problem. You are to find the first 5 terms. Meaning to say, you will be using the numbers 1, 2, 3, 4, and 5. And that numbers are the domain of the sequence. Now, substituting the values in the given expression will give the following terms. We have a sub 1 or the first term. Substitute 1 since this is the first term. You have 5 times 1 minus 3 is equal to 2. Then second term, 5 times 2 minus 3, which is equal to 7. And keep doing this until we have the 5th term. So therefore, the first 5 terms of the sequence are 2, 7, 12, 17, and 22. Using this nth term or the general term for this sequence. Another example, find the 8th term of the sequence whose nth term is a sub n is equal to n plus n over 2. Since we are looking for the 8th term only, we will be substituting 8 to our n, or automatically use 8 as the value of n since we are to find only the 8th term. So we have substituting 8 here in our expression, and we have the 8th term is equal to 8 plus 8 over 2. Then simplifying 8 over 2, we have 4. Then adding 8 plus 4, then we get 12. Therefore, the 8th term is 12. For the last part, I want you to answer this individual practice for you to check if you really learned from this discussion. And please comment your answers below so that I can check also. And that's all for today's discussion. Thank you for watching.